So what we're going to do first is we're going to learn how to do some moles to grams conversions. So based on the problem that you were just shown, what we're going to do is we're going to figure out how many grams of carbon dioxide are going to be produced when we have 40 moles of carbon monoxide that's going to react with an excess of iron 3 oxide. Now, when you see that word excess, don't get too hung up on it. All that means is that you have an unlimited supply of iron 3 oxide. So really, you're only limited on the amount of carbon monoxide you have. So that's all that means. So anytime you see the word excess, don't worry about it. It just means you have an unlimited supply of it, okay? So let's pull out that really important information that we need. So our starting point is going to be the 40.0 moles of carbon monoxide. And remember, what our destination is we want to know how many grams of carbon dioxide we're going to produce, okay? Again, I said don't worry about that excess of iron 3 oxide. You're not going to plug that in here at all. It just means you have an unlimited supply. So the very first thing we need to do is we need to convert from moles of carbon monoxide to moles of carbon dioxide. We can't just go straight from moles of carbon monoxide to grams of carbon dioxide. You have to do everything in moles first when you go from one compound to another compound. So remember, when we do that, what you need to look at are your coefficients, your mole ratios. So we need moles of carbon monoxide on the bottom. When we look up here, we have a 3 coefficient. So that means I'm going to put 3 moles of carbon monoxide on the bottom. Next, we need carbon dioxide up on top. I'm going to look at my coefficient for carbon dioxide. I have a 3. So I'm going to put 3 moles of carbon dioxide up on top. So the moles of carbon monoxide are going to cancel each other out. Now from here, at this point, we are now allowed to convert from moles of carbon dioxide to grams of carbon dioxide. Now in order to do that, this is where that molar mass comes into play. Remember how you figured out your molar mass? So over here what we're going to do is just do a quick little review for your molar mass, and we're going to figure it out for carbon dioxide. Now anytime you're doing your molar mass, remember you are not going to look at your coefficients whatsoever. The only thing you're going to look at are the elements and their subscripts, okay? So if you look at for carbon, carbon's atomic mass is 12.01. And it has an understood subscript as 1, so I don't have to do anything else to it. Oxygen has an atomic mass of 16.00. Now if you look at it, its subscript is 2. So that means I need to multiply this by 2. When I do this, I multiply this out, and then I add it to the 12.01. What I'm going to end up getting for the molar mass is 44.01 grams per mole. Now, this is really important to denote, okay, because your units for your molar mass will always be grams per mole. This is a conversion unit in itself. So this can also be written as 44.01 grams over 1 mole. So anytime you figure out the molar mass for a compound, it's always going to be over 1 mole, okay? That's very important to note because a lot of people will commonly switch up the numbers. What you calculated out will always stay with grams, and then for moles, it's always going to be just 1 mole. So what we're going to do is we're going to take this conversion factor, our molar mass, and we're going to plug it into the other part of our T-chart. So I need moles of carbon dioxide to cancel out. So that means this 1 mole right here has to go on bottom. And then the grams of carbon dioxide needs to go up on top. So I'm going to put the 44.01 grams up on top. Now my moles of carbon dioxide will cancel each other out. I've reached my destination of grams of carbon dioxide, so all I have to do here is just do the math. When I go forward and I do the math, I'm going to get 1,760.4 grams of carbon dioxide. Am I done? Nope, not yet. Remember, significant digits. So let's go back to our starting point. I have 1, 2, 3 significant digits. Again, remember, these 2 zeros are significant because they appear after a non-zero, so they appear after this 4, and there's a decimal present. So I need to go to my answer. I'm going to have 1, 2, 3. I round the 6 based off the number behind it, which is a 0. So that means I don't actually have to round it at all. So my answer is going to be 1,760 grams of carbon dioxide. Now it's very important that you leave this 0 in here. The 0 is not significant in our answer because there's not a decimal present. So that tells us we only have 3 significant digits. If you take out the 0 altogether, you changed it from 1,760 grams to just 176 grams. There's a huge difference, and it makes a huge impact on your results. So make sure you keep that 0 in there, okay? Now what we're going to do here is I'm going to set up another practice problem for you to do. So what I'd like for you to do again, look at the next slide. It's going to tell you what your practice problem is going to be. Push pause, practice it out. Once you're done with it, restart the video again, and then we'll work out the problem together.